Guys, hope you are doing well. I'm Kumar K, your favorite DSA teacher. When it comes to solving hard unseen DSA problem, which requires lots of complex logic and intuition, okay, hard unseen DSA problems of online assessments, online tests of top tech companies, and competitive programming and coding contest problems. Today, I'm very happy. Think why I'm happy. I'm always happy when my students get selected. So, guys, if I go to the document, this document link will be there in the description of the video. Okay, many of you keep on asking me where is the material is in the description of the video. So guys, the first thing, congratulations to my student for cracking a great offer, very high paying offer off campus from Amazon. Okay, despite not being from a top tier college, she cracked it off campus. My student did it. Congratulations to Sukriti. She has been training very hard with us for DSA, OA, CP, one-to-one mentoring, referrals, everything combined. After 8 to 10 months of hard work, Sukriti has generated the offer. She was a beginner few months back, but now she is awesome at DSA, OA, CP, and she has offer from Amazon off campus. Similar to her, guys, 2 days back this happened, and then 5 days back another student of mine cracked off campus offer from Amazon. Like, there have been so many selections in so many companies, but in today's video I'm thinking of mentioning the Amazon one because it reminds me of my days when I got the Amazon offer a few years back. I was very happy. So Harini, congratulations for cracking off campus offer. She has worked hard since 10-15 months. I know her. I know her struggle. Then, guys, congratulations to Abhirami as well. She has also cracked a very great offer from Amazon. So, congratulations to her. Great job. Great job. So, like this, on a daily basis, we have many selections. Okay. Now, coming to my introduction, I have previously worked at Amazon and Mia.net as a software engineer. And coming to our love for DSA, I have All India Rank 12 in Google Code Jam 2021 and All India Rank 4 in the recent Facebook Hacker Cup. So, guys, if you want the best level DSA plus OA plus EB training in the country, you can join our one-to-one mentoring and personalized training program, where all the live classes are by me, and you get the one-to-one mentoring with me as well. Also, you'll get full stack development feature, system design training feature. You will get referrals of top 500 companies. Many things are there, and we have selections on a daily basis. So if you are interested, you can check the link in the description. We have special offer of New Year on the new batch which has been getting launched. Now, guys, today we are going to solve very interesting problem. Everything is making me so happy today. So hello guys, with the name of God, Ram Ram. We congratulate our student Kaustav Halder for cracking Apple, getting selected in Apple. We gave him daily live DSA plus OA plus CP training for more than 10 months, and he has generated this brilliant result. Really happy for student Kaustav there. So, guys, this was the problem which was asked in Rubrik online assessment some time back. We don't have the exact image of the question, but as per the student's memory, this was the problem. So, you guys can pause the video and read the question and try to understand as much as you can. So, whatever they are trying to say, they are first trying to ask you. First, let's discuss some easy questions because the rubric OA is a little bit difficult. Only then you will get the CTC of 80 lakhs as for a fresher SD role, right? So, what they are trying to tell you is that if I give you any n, how many arrays of size n are possible? For k equal to 2. So that basically means that let's say n is equal to 2 and k is also equal to 2. So how many arrays of size 2 are possible? How many arrays of size 2 are possible? Each number, like in the first position, you can either put any number in the range 1 to k. So k is 2. So you can either put 1 in the first place or 2 in the first place. Similarly, you can put 1 in the first place and 2 in the first place. So total, how many sequences will be there? One sequence will be 1 comma 1, another will be 1 comma 2, another will be 2 comma 1, another will be 2 comma 2. So there are total 4 sequences, guys. There are total 4 sequences possible. So how do we calculate that? The formula is pretty simple. Here there are k options. Here also there are k options. So you multiply them, right? To generate all the options, k square. Now, why did this work out? Here there are k options. See, na, k is equal to 2. Here you can either put 1 or you can either put 2. Here also you can either put 1 or you can put 2. So imagine like this. At the first place you can either put 1 or 2. In the second index you can either put 1 or 2. So this one can combine with this 2 and generate array. This one can combine with this 2 and generate array. This 2 can combine with this one. This 2 can combine with this 2. So two options here, two options here. You multiply them, total four options will come. So k raised to n is the answer for any array n. I give you any array n. I tell you that, hey, tell me how many arrays are possible of size n. Okay, how many arrays are possible of size n where the each index guy has to be something from 1 to k. Each index you can replace by a number from 1 to k. Each index you can replace by a number from 1 to k. So, lovely people, listen to me. I will tell you the best answer for this. Here there are k options, right? From 1 to k. Here also k options. Here also k options. Here also k options till the end. So you will multiply all these k's, right? But guys, the k is getting multiplied how many times? K is getting multiplied n times. So the solution is k raised to n, because you're multiplying k n times. Okay. So the rubric is asking this only, that like I give you an array, tell me how many arrays of size n are possible where at each place you can put k numbers. Like at each place you can put any number from 1 to k. So k, any one of the k numbers you can put here, any one of the k numbers you can put here. So it is k raised to n. Well, this much is clear. But now Rubrik has added some conditions to this problem. Like, let's say n equal to 2, k equal to 3. So for this case, the answer is simple, right? You know, here you can put any number from range 1 to 3. Here also you can put any number from range 1 to 3. So three options here, three options here. So it is 3 square, which is nothing but k square, which is nothing but k raised to n. K is 3, n is 2. 3 square. So nine arrays are possible. So for any array, the answer is k raised to n. That much is clear to you. Now, the nice thing about the rubric way problem is that, guys, this thing we understand that if you just want to count the number of arrays whose size is n and you are allowed to put any number from 1 to k at each index, the answer is k raised to n. But now, guys, you are given one more array d. These d array is also given. D of n denote the conditions. D of n will denote you the conditions. Okay. So basically, D1 means B1 should always be greater than B of D1. D2 means B2 should always be greater than B of D2. So like this, there will be n conditions given to you. And if there is no condition, then the Di will be negative. And guys, all the positive elements of D are distinct. Okay. So this is a very important condition to solve the problem. If they were not distinct, we would have to use tree and dynamic programming, which is a nice harder version of it. Okay. And further more complications would be there in the question if the sign was greater than equal to. But here they have kept it a little simple, only strictly greater than sign and simple conditions. Okay. So guys, what is the meaning of these conditions? Let's take this example. N can be as big as 10 raised to 5 and will be less than equal to 10 raised to 10. Okay. So n equal to 3, k equal to 5. N equal to 3, k equal to 5. Okay, guys. N equal to 3, k equal to 5. So how many such sequences are possible? Here you have 5 options. Here you have 5 options. Here you have 5 options. 5 into 5 into 5. 125 is the answer. But. Now a D array is also given to you. What is the meaning of the D array, lovely people? 2 minus 1 minus 1. 2 minus 1 minus 1. So minus 1 you can ignore. But the positive number 2. Do you know what is the meaning of this? The meaning of this is that B1 should be strictly greater than B of D of 1. The array which we are going to generate na, in that it is compulsory that the first element should be strictly greater than B of D of 1. What is B of D of 1? D of 1 is 2. So B of 1 should be strictly greater than B of 2. So guys, can you tell me how many, permutations and combinations? How many sequences of size 3 are possible such that the first element is always bigger than the second element? Not hard to decipher. The first element should always be bigger than the second element. So let's say the k is given to us is 5, right? So guys, if 5 is the first element, for the second element, we can put any number from 1 to 4, right? Yeah. If 4 is the first element, we can put any number from 1 to 3. If 3 is the element at the first position, we can put any number from 1 to 2. If 2 is the element, we can put here 1. If 1 is the element at the first index, then there is no possibility. So let's not write it. So 4 options are here in total when the first number is 5. If the first number is 4, then there are 3 options. If the first number is 3, there are 2 options. If the first number is 2, there is only one option, which is 2 comma 1. So 4 plus 3 plus 2 plus 1, 10. So the thing is that guys, there are 10 ways to fill the first two places. You had to fill these 3 places. There are 10 ways to fill these places. Which are those 10 ways, guys? These are the 10 ways. It is confirmed in all those 10 ways. This first element will be greater than the second element. Okay? Is there any condition on the third element? No condition is there on it. No condition is there. So you can put any number from 1 to k, 1 to 5 here. So 10 multiplied by 5, it is 50 ways are there. Hopefully you like the little bit of maths and combinatorics going on here. Okay? Love you all. Love you all. So the output is 50. Like this, there are a few more test cases. You guys can check it out. Okay? So n equal to 3, k equal to 5. Okay? So guys, the thing is that we just have to understand how to count these things. N equal to 3, k equal to 5. N equal to 3, k equal to 5. So listen to me very, very carefully, guys. Okay? So what I am trying to say is that this time the conditions are like this. This is the D array. 2, 3, 1. Okay? And this is the B array. Okay? So the first condition, okay, it is not 2, 3, 1, it is 2, 3 minus 1. Okay. The first condition is that B1 should be greater than B of D1. So what is D1? D1 is 2. So basically, first element should be greater than second element. And the second condition is that B2 should be greater than B2 of D2. B2 should be strictly greater than B of D2. What is D2? D2 is 3. So B2 should be greater than B3. So guys, all the elements should be in ascending order. B1 should be greater than B2 and B2 should be greater than B3. B1 should be greater than B2 and B2 should be greater than B3. How many ways are there to make the numbers such that all these conditions get satisfied? Nice exercise, right? Nice exercise. You need to know, find out how many sequences will be possible such that this guy will be strictly greater than this guy will be strictly greater than this guy. Okay, so one of the sequence will be, I think, 5 4 3, right? Another sequence will be there are many sequences like 5 4 2. Another sequence will be 5 4 1. Okay, so 5 4 3, 5 4 2, 5 4 1. Then there will be 5, 3, 2. Then there will be 5, 3, 1. Okay. Then another sequence will be 5, 2, 1. And I don't think anymore. Yeah, you cannot write 5, 1 because there is no element greater than 1 for the third element. Okay. Now let's start with 4. So 4, 3, 2. Then there will be 4, 3, 1. Then there will be finally 1, 2, 3, 4, 5, 6, 7, 8. Just let me think. Yeah, 3, 2, 1 though will always be there. So guys, Ram Ram, there will be total 10 sequences which are in strictly ascending order, like B1 strictly greater than B2 strictly greater than B3. So the answer for this is 10. So guys, but how do we solve these challenging problems, hard unseen DSA problems? How do we build our thinking skills for them? How to do that? What we can do is that after understanding this much of the question, we come to know that the actual conditions, when they all mix up, it can be very, very problematic, right? They have given you N, they have given you K, they have given you D. So let's say this is the D array, okay? Now you have to construct all the valid array B, all the valid arrays B. Now the nice thing is that D will either have -1 or a positive number, or minus 1. Either if something is positive, let me write plus V, or it can be negative, or let's say it can be positive. Okay. So the D can either have positive numbers or negative numbers, but the nice thing is that all the positive numbers will be distinct. They will all be different. They will never match each other. Okay. So guys, after going through this question, you understand that for it will happen multiple times. Actually, it will happen multiple times. What will happen multiple times? That bi should be strictly greater than b of di. Now di is a distinct number. So how will the conditions look like if you try to make a diagram of the condition? Let's say there are many such conditions. Let's say b1 is greater than b of di and di is 2. So you can say 1 is greater than 2. This is the first condition. Let's say next condition is b2 greater than b of d2, and d2 is again a distinct number. Let's say d2 is 5. So 2 should be greater than 5. Then let's say the next condition is 3 should be greater than 6. Let's say the next condition is 4 should be greater than 7. Let's say the next condition is 6 should be greater than 8. So this is how you can visualize in your mind that okay sir, I agree with you that the conditions, when you try to draw a graph out of them, you can visualize how the conditions will look. If it's clear that b1 has to be greater than b2, you can make a edge in the graph from node 1. You can consider them as nodes. That yeah, there is an edge from node 1 to node 2. So like this the conditions will look like. Hopefully that is clear to you people, that this is how the conditions will look like. Now guys, what I want to say is that the conditions will always be linear in nature. For example, this is the node. If it's given that the node 1, the element at index 1 should be greater than 2, it should look like this. Then it will look like this. Let's say it's written that the element at index 2 should be greater than element at index 5. Then the element at index 5 is greater than element at index 8. Then the element at index 8 is greater than the element at index 10. Okay. So I am saying that it will always be linear. It will never happen that your condition looks something like this. Basically, this is not possible. Each node will have only one outgoing edge, and only one incoming edge. So this is what I have written in the. This is a brilliant observation, by the way, that make a directed graph. Each node can have only one out degree and one in degree. Okay, so the graph will generally be linear, directed tree. If it's not a tree, linear tree, then it's a cycle. Then if it's a cycle, then the answer is zero. So guys, why is this not possible? I am saying that this graph is not possible where 11 is pointing 5. Why? Because it is known that B2 should be greater than B5. And 5 is nothing but one of the values of the D array, right? It is D of 2. Now, B11 greater than B5 is never possible. Why? Why is it never possible? Because the inside number is 5, which is of the D array. And the D array has all distinct positive numbers. So one time if a 5 has come, now it can never come again. So that's why two nodes can never point to one node. So this is the main observation. Two nodes can never simultaneously point to one node. This will never happen. Okay. So guys, the basic thing is that if you try to make a graph out of these things now, you will find like distinct patterns. Okay. Let's say you are given n equal to 5. Okay. N equal to 5. N equal to 5. K equal to 10. Okay. Okay, so and let's say this is your D array. Now guys, if I try to make the like if I try to solve it via the node thing, how will my graph look like? My I can see that index 1 2 3 4 5. So b1 should be greater than b of d1. What is a d1? 3. So b1 should be greater than 3. So b1 should be greater than 3. So I make a edge like this. 1 should be greater than 3. Okay? Okay. Now at index 2 there is 4. So second element should be greater than the fourth element. At index 3 there is 5. So third element should be greater than the fifth element. So guys, can you see how the graph is looking like? There are two linear graphs, two components. See, you can separate them and it's looking like this. See, one is pointing to 3, 3 is pointing to 5. Another will be 2 is pointing to 4. So there are two connected components. Don't worry if you don't know the meaning of graphs, connected components, BFS, DFS. In this document for you lovely people, I will add the prerequisite premium videos of mine. You can watch them and then get back to this session. Love you. So you can see that one component is 1 to 3 to 5 and another is 2 to 4. So for each component, you can try to find the number of ways to put numbers here so that they are in increasing order. Each component can be solved independently. Okay. So hopefully this got clear for you people, right? 3 4 5 minus 1 minus 1. So guys, let's try to solve one particular connected component. How can I solve the one particular connected component? Let's say the component is like this: 1 2 5 8 10. Okay. Let's read it one more time. Yeah, b1 needs to be strictly greater than. Okay. So let's make it look like this, that the first element should be greater than, like I prepared it for you people, but let's keep it greater than like this. Okay. So guys, let's say this component is coming after making the graph of the array. It is given that the first element should be bigger than the second element, should be bigger than the fifth element, should be bigger than the eighth element, and that the eighth element should be bigger than the 10th element. And let's say it is given to us that k is 15. K is 15. So guys, do you know how many ways are there to select numbers such that we get an increasing sequence of 5 numbers? So the solution is you write all the 15 numbers in descending order. 15, 14, 13, 12, 11, 10, 9, 8, like 10, 9, 8 till 1. So you have written all 15 numbers in the descending order. Okay. What is the number of ways to choose 5 numbers from these 15 numbers? You know the basic mathematics. How to choose 5 numbers from 15 numbers? 15C5, which is 15 factorial upon 5 factorial upon 15 minus 5, 10 factorial. NCR is nothing but number of ways to choose R items from N items. Please remember these things, okay? NCR, this is a basic mathematical concept. NCR. NCR is nothing but let me write here. KCR is nothing but, let me write there. Hmm. Like in the NCR is nothing but, let me write here. Number of ways, number of ways to select, number of ways, number of ways to select R elements, number of ways to select R elements from K elements. So guys, why is this working so brilliantly? Why 15C5 का मतलब मालूम है क्या? What is the meaning of 15C5? That you are able to select 5 elements from the 15 elements. So guys, there are these many ways to select the 5 elements, and all these ways will make in increasing sequence. All these ways will make a decreasing sequence, sorry. Okay, why? Let's take any one way. One way will be what, guys? One way will be what? To select any 5 numbers from this sorted numbers from 15 to 1. You can say na 15 comma 10 comma 9 comma 8 comma 7. Sir, this is one valid way to select 5 numbers out of these 15 numbers in descending order. The nice thing is that this one way is a valid way to substitute for this graph. Here the first number you can put it as 15. Here you can put it as 10, 9, 8, 7. And it is satisfying all the constraints. See, this is strictly greater than this. 15 strictly greater than 10. 10 strictly greater than 9. Strictly greater than 8. Strictly greater than 7. All these numbers are in strictly decreasing order. So guys, the problem has been solved. Let's say R is the size of the component. R is the size of the component. Then how many ways are there to put strictly increasing numbers? Strictly increasing numbers. So there are total k numbers we have, right? Distinct k numbers. So from these 15 numbers, I just have to, from these 15 numbers, if I write these 15 numbers in descending order, I just need to know the number of ways to choose R numbers from them. So 15CR, KCR is the answer for a component which is linear in fashion. Okay. So the component will always be linear in fashion only. This case will never happen. It will never become a general directed tree because two nodes can never point at one node. Okay. So this thing is clear to you. For each component, KCR is the answer. The number of ways to put strictly decreasing numbers in the fashion as we want. Okay, so there are KCR ways such that the first number greater than second number greater than fifth number greater than eighth number greater than 10th number. But guys, there is one corner case which we did not solve. What is that corner case? A cycle can be formed sometimes. A cycle like this can be formed. a cycle like this can be formed. Now the answer will be 0. Why the answer is 0, guys? Because you know this, that you want, let's say 10. You want this number to be greater than this number. Okay, you can put a 9 here. You want 9 to be greater than next number. You can put a 8 here. You want 8 to be greater than next number. You can put a 7 here. You want 7 to be greater than next number. You can put 6 here. You want 6 to be greater than 10 again. Oh, this is not possible, guys. If a cycle is coming, it means it is not possible. Zero way to make this. Okay, cycle is not allowed. So guys, the problem is solved. The question is also now solved. All you have to do is that we will solve for each component. We can know the number of ways to satisfy that component after making the graph, right? Finally, we will multiply the answer of all connected components. For example, let's say k is equal to 10. So guys, if I make a graph out of this, first element should be greater than third element, should be greater than fifth element. Second element should be greater than the fourth element. Okay. So guys, what will be the answer for this? How many ways are there to select three numbers which are in decreasing order? So I write all the 10 numbers like this in my mind. All the numbers from 10 to 1 in the descending order. How many ways are there to select three numbers from this? It will be 10C3. 10C3 will be the answer, guys. 10C3 will be the total number of ways. Because if from these numbers, or like these numbers 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, I can select any three numbers, right? This, like this. So I can select any three numbers, right? And those three numbers will be in decreasing order like this. So 10C3 ways. And for this, guys, how many ways are there? Again, you just have to satisfy this. You just have to select any two numbers from 10 to 1. So it will be 10C2. What will be the final answer? Will be multiplication of both of them. 10C3 multiplied by 10C2. Why did I multiply? Guys, because whatever are the sequences of the first component, they are independent. They are independent of the second component. यहाँ पर जितने भी सीक्वेंसेस आ रहे हैं और यहाँ पर जितने भी सीक्वेंसेस आ रहे हैं वो उन दोनों को कंबाइन करना है. दोनों इंडिपेंडेंट है, दोनों को मल्टीप्लाई मार देंगे, समझे? Let's say like I will give you a simple example. Let's say for this there are three sequences are there. Let's say like 3 2 1 5 2 1 5 3 1. Let's say there are three sequences such that they are in strictly ascending order of three numbers. And here let's say there is let's say there are two sequences, 2 greater than 1, 5 greater than 1, or let's say 10 greater than 1, such that the two numbers are in increasing order. But guys, if you want to combine all of them, then how many ways will be there? Here there are three ways. Here there are two ways. So 3 into 2, 6 is the answer. Hopefully you loved the problem. Why are we combining? Because we have to fill the places of 1, 2, 3, 4, 5, right? So if in 1, 3, 5 I write the numbers 3, 2, 1. 3, 2, 1. This is 1, 3, 5. Okay. This should be greater than this. This should be greater than this. And at 2, 4 I write 10 and 1. This should be greater than this. Now the nice thing is, guys, that here for this bond there are two ways. And for this bond, na 3, 2, 1, there are three ways to write the sequences. So here I can write two different sequences. Here I can write three different sequences. If I try to combine all of them, there will be six sequences. One time this sequence 3 2 1 and 2 1, one time 3 2 1 and 10 1, then one time 5 2 1 and 2 1, then 5 2 1, then 10 1, then 5 3 1 and 2 1, and then 5 3 1 and 10 1. Hopefully even the beginner could understand. So guys, this is the solution. If I go towards the implementation, we will try to make the edges. Like the edges will be there, okay? The edges will be generally from I to D of I, okay? If I try to make it easy for you people. The edges will be from I to D of I, okay? Edges will be from I to D of I, indicating that the ith element has to be greater than D of I. Okay, so you just make an edges like this, or you can even call it that the edge is from Bi to Bj, such that J is equal to D of I, which is nothing but I to D of I. Okay, you make a graph with the edges, find all the connected components using BFS DFS. If you don't know how to do this, don't worry, I will attach the videos, you can watch them. And guys, for each component you calculate KCR for each component, where K to you already know, R is the size of the component, and then finally multiply all the answers and take the modulo brilliantly, and the problem gets solved. There are few nuances like how to calculate NCR efficiently using modulo. All those references will be attached. All the best, hope you guys liked it. Ram Ram.